Okay, let's continue with the main subject of this week, which is rendering. Hopefully will be a little bit more interesting than the main loop was. And there's been a trickle of some extra people, maybe nearly 30 people in now, which is not too bad. All right, rendering, part one. So when I say rendering, I'm just talking about drawing an image. That's what the word means, from its constituent parts. So that's all we're talking about, nothing fancy. Yes. The other thing I should point out, I've said this before, but when I talk about rendering, that doesn't mean 3D rendering necessarily. 2D rendering is a thing, and that's what we'll be doing in this course, because I haven't really got time to teach you 3D stuff. But a lot of the things apply across both. You know, most of the things I'm talking about drawing kind of 2D shapes and stuff, but 3D is very similar ultimately. And at the end of the day, when you're doing 3D, basically the way it works is that things are built out of triangles, with some exceptions, and you end up drawing the triangle as a essentially two-dimensional object when it's finished. It's just that when you put them all together, it looks like a 3D one. And this is where we introduce HTML Canvas. Do any of you know about HTML Canvas? You're already familiar with it? I've got a couple of nods, but how many of you don't know about HTML Canvas? Most of you. Okay, good. You'll learn something then. And it's quite fun. So it turns out that when the HTML5 standard was put together a while back, that's like maybe getting on for 10 years now, admittedly, they belatedly added a thing called Canvas to the DOM. And this is what we're going to use for our game rendering. And Canvas is just what games programmers had been waiting for on the web. Because without it, if you're trying to do stuff on the web, you know, remember that the basic facilities in HTML are very primitive. You know, you've just got simple text and images. You can't control the layout very well, or if you want to, you have to resort to CSS, which can be a bit of a pain at times. You know, you've got kind of tabular layouts and stuff, but this isn't what you want for a game. I want to have like Space Invaders, and I want to have one over here and one over here, and I want to move them around and do whatever I like. Why can't I just do that? Why can't I just draw stuff where I want it? And on the web, you basically couldn't until this came along. So the nice thing about Canvas is it lets you just draw arbitrary shapes within the web page. What you do is you declare a rectangle in the web page that is your canvas area, and then you've basically got control over, you know, exactly what gets drawn in that space. You control all the positioning and layout yourself, and that's what you want. So let's just do it. Let's go in there. So JS Fiddle is quite convenient for doing this stuff. What I like about it is it allows you to have your code and the output of the code side by side, which is quite nice for teaching stuff. It's also quite nice when you're working on it, just to have that convenience. So we're going to run through some Fiddle stuff, and I'll show you how Canvas operates. So here are the relevant links, which I'll just bring up. Might have to do a bit of resizing though, because it's the slight problem is that the screen space can be a bit of a pain when you do this, because you need enough space to have the text and you need enough space for the output, which is a bit constricted here. I'll try and pull it in a bit. Yeah. Okay, so from my point of view, I can see that point where there's an edge on the projection board, but does it look okay to you? Can you basically see okay where I put the mouse pointer? Yeah, it probably looks better to you than it does to me. I've got very bad parallax because I'm at an angle. All right. So here we go with Canvas. So up here in the HTML part of the page, I've just got a Canvas element, which is just like anything else, like a div element or an image element, right? It's called Canvas. You give it an ID so that the code can refer to it by name. It's useful. And some standard properties that it has are width and height, which I'm setting to 400 pixels each here, just for practicality. And there's some other things you can do. You can put a style on it, and I've done that. I've put a 1 pixel border on it, just so that it's very obvious to you which part of the page out here is actually the canvas area itself. So that's step one, right? Okay. But we haven't got any content yet, because there's no JavaScript. We haven't done anything with it. We've just declared it. So let's do something with it. Hello world. Can't beat the classics, eh? So we've got some code here now, and it's very simple. What we're just doing is going into the document, which is just, you know, the web container for the whole DOM, and saying, okay, find me the my canvas thing, please, which it finds because it's conveniently there, and you've now got a canvas variable. Then when you get the canvas variable, you do one other important thing, which is you say you want to get a context. Now the context is a kind of a secondary interface that you use to let you talk to the canvas, and that's what all this stuff is based on. And it turns out there are different contexts that are available, but we want the 2D one, so we just say get context 2D, and that should get you back a little wrapper object that you can use. Now, if you're being strict, you would maybe call that context, but the problem is we'll be using context so much today, almost every line of code will have the context in it, so that's one of these cases where you can afford to use an abbreviated variable name, even though it's maybe slightly bad form, because if you're going to use it all the time, you want it to be short so you know what you're talking about. So I think CTX is the most tolerable abbreviation that I could come up with for context, so that's what we're going to call it. And then once you've got that, you can now use that to do stuff. And here's another very simple example. You take the context and you say, I want some filled text, and then you have 3 parameters here. One is the text string, and then one is the X and the Y position at which you draw it. So that's simple enough, and you end up with that over here. A little bit of a subtlety about the X and Y. You can probably imagine that the X coordinate is the number of pixels left to right in the conventional, X-axis way. What about Y-axis though, right? Because you've got options with Y-axis. If you've got like graph paper, you're doing standard maths, usually Y goes up, doesn't it? So Y0 is down here when you're doing like a maths graph, and you make the Y go up the way. You probably know that with computer graphics, usually it's not that way. We make Y go down, basically to reflect the chronology of how screens get updated. Screens get drawn from top to bottom, canonically, like old televisions used to get drawn top to bottom. So that's part of the reason it goes that way. But there's an additional little quirk here, that this Y coordinate, normally, in the same that if the X coordinate is usually the leftmost coordinate of the thing that you're drawing, the left anchor, right? In a way you would think that, well, if we've got Y going down, the Y coordinate should be the topmost position. And for a lot of things it is, but not for text. Why not for text? Because different letters have got different heights. So imagine if you wanted to draw a bunch of text letters and you drew them individually. Let's say you were doing hello, H-E-L-L-O, right? And some of those are tall letters, some of those are short letters. So if you did those with X, Y, and the Y meant down from the top, the problem was your I think they don't call it kerning, the baseline of the letters would all be wrong. They'd all be magnetized up the top, the H-E-L-L-O, which is not what you want, right? You need to come up from the bottom. So in the special case of text, the rules kind of go slightly backwards, and the Y coordinate actually reflects the baseline that you want the thing to be drawn on, which turns out to make sense, even though it's just slightly not what you would expect. Which I think I can maybe illustrate. If I change this to the 0, you would see the difference, because it won't be hello canvas world attached to the top. You actually probably won't see it. I haven't done this, so I hope I'm right, but it'll be invisible, yeah, because you've said I want you to draw you on a baseline of 0, so all the letters are now above the baseline, so you can't see them. Right, so that's a bit of text. That text was quite small looking though, and one might hope that you can do something more attractive with it. Turns out you can. So all I've had to do here is it's exactly the same piece of code where I call the context, and I've still used 3030, the original coordinates that I had, but if you remember that it is higher up now than it used to be because it's grown from the baseline. And there's one other thing that I did, which is I specified a font, and that was both a font and a size, so 30 point Arial, and that's how you tell it what to do. Now, already there's something kind of interesting here about API design, like why it is done this way and not some other ways. The other way this could have been done is the fill text routine. Do that. The fill text routine could have taken extra parameters to specify the font and the size, couldn't it? That'd be quite sensible. And then you would say, it'd be self-contained. What the text routine would say, what do you want to draw? Where do you want to draw it? What font, what size, what colour, what anything else you want to do, just put them in as parameters. And that would mean that when you looked at the fill text line, you would know exactly what was going on. It would just be explicit. But Canvas doesn't work that way because it uses the context thing. The idea is that sometimes what you do is you call an apparently unrelated function on the context that sets up some kind of background thing that has an effect on subsequent code. That's what's happening here. So when you see them one after the other, it's kind of obvious what's happening. But in a real program, this setting here could have been like pages of code away. You could have called this inside a different function some earlier time, and then when you come down here and do fill text, it's having a side effect down here instead. And this is one of the big things about relying on a context system. The advantage of it is that it stops you having to have explicit parameters all the time on all your other calls. Like, when I say fill text, I don't have to keep specifying the font over and over again. But it also means that the font, it becomes implicit. So you can't just look at a function and know what it does. You have to say, I can look at this function, and that tells me some of what it does, but the rest of it depends on this, sort of opaque context object that has been manipulated by other people at other times. You don't necessarily know, but that can have advantages too. It's allowing you to wrap up all that state in a way that is sometimes convenient, but it's an interesting choice to use context carrying rather than explicit parameters, and Canvas goes for context carrying. All right, so that was a bit of text. And just another example, another context thing is called fill style. Now it's called fill style, but one of the things that you specify in the style is color. It recognizes certain standard color words, that of the type that, all the kind of obvious ones are just built in, so you can just type them in as words. But you can also type in RGB color values if you've got those, but we're just going to stick with simple words because it's very human readable and convenient. So again, very simple. Again, notice that the fill text line itself has not changed, but what it does changes. It now draws red text instead of black text because of the side effect of the context. Whoa, fancy stuff now, yeah. So we've got the same stuff as we had before, but now we've got a new thing, a filled rectangle, and we've got a stroke rectangle underneath. So let's look at the filled rectangle. It's kind of what you would expect. To get a rectangle, you're going to want to know its coordinates, and there's really, you've got kind of two obvious choices for that. One would be to specify the XY coordinates of the top left, and then the XY coordinates of the bottom right. Or you could specify XY of the top left, and the width and the height. And Canvas has decided to go for the width and height approach. And of course, I mean, it's, we have an English expression, 6 1/2 a dozen. It's just two ways of saying the same thing. Doesn't really matter too much. But do you think, is there any particular reason why you might prefer to put width and height as the second parameters rather than the bottom right coordinates? I mean, it doesn't ultimately make a difference, but why, if you were designing the API yourself and deciding whether to use top left, bottom right, or top left, width, height, would you have a preference? Would it matter? Okay, well, one thing that I would say is slightly advantageous about width and height is it makes it easier to move things. Because to move things, you just change one position. If I want to move this to the right, I just change the x coordinate, and then when I run it, the whole thing budges along, or if I did it a bit more aggressively, so you could see it more. Right? Whereas if you did, the two endpoints, I'd have to actually calculate the bottom endpoint in order to have the object retain its size. And how would I do that? Well, I'd add on the width and the height, and I'd compute it, right? So it's like, yeah, when you think about it, if you imagine a shape as being like a coherent visual entity, it has got a width and a height, and you'd want to preserve that when you moved it. So this approach allows that to just be like the automatic thing. You have a question?
I think you can, instead of clicking on run, you can do control method. So
okay. Now, will that just run it and not create a new iteration? Though I don't want to save it, I just want to run it.
I don't think it says.
Okay, I'll maybe try that, although if it saves it, it'll throw me off my stride, but I might try it. Okay, so let's just move this back to where it was. So just a little kind of, again, little API design note. Shall we try, did you just control enter?
I think so.
Okay, boom, well done. So it makes it slightly easier to move things. So that was a filled rectangle. There's another type of rectangle you can draw, which is an unfilled rectangle, but they call it stroke rect, where stroke defines the outer shape. So like this, instead of, because you notice this one doesn't actually have a boundary on it, it's just a filled area, whereas this one here has got a boundary and nothing filled. Do you notice anything else strange about stroke rect? there's just like a very obvious slight surprise about it compared to fill rect.
It's not red.
It's not red, right? But that's because when we set red up here, we set the fill style. So fill style applies to filled shapes. What do you think would allow us to change the colour of the stroke rect?
Stroke style?
Oh, amazing. Got some geniuses in. So I haven't actually done it yet, but you are right. There's a stroke style, and if you use that, it'll change what that looks like. In fact, maybe the fairest way to do that would have been if I'd done context stroke style, and let's just make it red so everything is like. And again, Control Enter. Yep, and it did change. It's not totally visible, but it's red now. So as advertised, that works. Right, but now, not only is this rectangle over here filled, it's actually not got a single colour in it. It's got a whole bunch of different colours in it. What's happened here is we've got a gradient fill, it's called. It's where you fill something with not one colour, you fill it with a spread of colours. And that's something that Canvas has got built in. It's quite nice. And the way you do it, you have to jump through a couple of hoops, but it's not terribly difficult. Again, the interesting thing is, if you go and look at the fill rect itself, it's the same old fill rect that it always was, right? There's nothing here that says, oh, and by the way, I want it to be a bit red and a bit green and something in between, right? Because again, it's all context-based. The trick is, before you draw the rectangle, you set up the context to have a fill style that instead of being red, is now gradient. And gradient isn't a string, it's not gradient, it's a variable called gradient that I created up here. So, and this is just how the API works. There's a thing you can do where you create, in this case, a linear gradient. So you create a linear gradient. I'll explain the numbers in a second. So you've now got a gradient object, and then you do something called adding color stops, which is where you specify the colors that you want your gradient to have, and then you fill things with it. So what's happening here is with the linear gradient, you imagine that you are drawing a line. So the question is, where is that line? And it's again, it turns out for the linear gradients, they actually use a top left, bottom right coordinate system because who cares about consistency? So this one is going from 0, 0, which imagine being up there, to 300, 0, which is just a bit over there. So there's this kind of invisible line called the gradient. And then what you do is you imagine that gradient as having points along it that are described by a parameter that goes from 0 to 1. So 0's like the start point, 1's the end point, 0.5's the middle, 0.25's a quarter in, right? Just a parametric coordinate. So having established what the gradient is, I can now say that at position 0, which is the kind of left part of the gradient, I want it to be red, and at position 1 at the end, I want it to be green, and that's the way it is. And then what happens is, this line's got a direction on it. The current one, it's like totally horizontal, right? So imagine that invisible horizontal line that goes from red to green. And then the idea is that if you extend that sort of perpendicularly, so you imagine taking the colours that are on that line and you just spread them all the way down the screen, you would get these bands of red and green, and that's what you get. So when we come down here and we draw the rectangle, the bands of red and green flow down, as indeed it flows through the text as well, so you can get colourised text. Again, it just kind of happens for free. So to give you a bit more of a kind of mental insight as to what's going on with the gradient, if I, instead of saying I just did a horizontal line that's 300, 0, if I put an angle on it and I made the line go like that a little bit, so that it went to 300, 200, say, that would be a slightly diagonalised line. And if you run that, you'll try and mentally imagine how that changes the gradient, and then think about how that would be projected perpendicularly to the rest of the screen, and hopefully you can sort of see in your head what it would do. Okay, so now you see that this dividing line between the red and the green is a kind of diagonal now, whereas previously it was a vertical, and that's because it's diagonal from a gradient line that's somewhere down here. So it's not the easiest thing to see, but that's what's going on. Having done that, there are other things we can do. We can play about with these colour stops and so on. In fact, the next iteration will show you that. There we go. So we've gone back to the straight gradient, but it's got at least 3 colours in it now. More if you include all the intermediates. So you can see it's starting kind of red, and it's going through yellow, and then finishing off with green. And that was a very simple change. All I had to do was just add a new colour stop with yellow in it. and it created this kind of much richer looking thing. And there were other things I could have done. If I'd made it blue, that would have worked as well. So that just happens for free. Does anyone notice what's visually changed on this one? It's different to the last thing I showed you. Somebody said the contrast, but it's not that. I think somebody else did say it. The stroke, right, yeah. If you look down here, you'll see that I set stroke style to also be the gradient. So instead of that just being the default black stroke, it now picks up the gradient. So this outer box here has also got colorized. So that was that. Whoa, fancy stuff now, eh? All right, so you can see here what I've done is I've replaced the rectangles with these non-rectangular shapes. And I guess it's a bit more complicated, but it's not, it's not rocket science. So it turns out that you can draw general kind of bounding shapes in Canvas fairly easily through a thing called a path. And again, it's all done inside the context. So the way it works is you start by saying you want to begin a path, and imagine that's like kind of you're defining a new shape, saying, okay, I'm going to start a shape now. Then once you've got that, you can do things like moving, which would be like moving your virtual pen to some point of the screen. And once you've got that moved position, you can then now draw a line to somewhere, draw a line to somewhere else, and a line to somewhere else. And that's exactly what's happening here. So we've moved to 30 across and 100 down, which should be 30 across 100 down, be there. And then we do a line to 300 by 200, which would be, actually, I think 300 by 200 is that one down there, isn't it? And then you go from there to 250 to 120, which is that one. And then you go back to 30 by 100. So I've drawn this triangle in the counterclockwise direction, which actually you often do in graphics. There's a slight convention that you use counterclockwise order for shapes. You might find that in 3D as well. It's a convention, so it's not always the case, but it's sometimes done. Okay, so that's me just kind of drawing that basic thing. I'll point out there's a bit here where I do line to 30 to 100 to draw back to the starting position. There's a shortcut for that. Rather than me having to remember what the starting position was, I could have just said close path. And what close path does is it just does a line to the first point you started from. But it's important to understand that close path is not the same as end path. It doesn't terminate your path. It just makes it go, but it just adds a point that happens to be the start point. This is actually very confusing, I think, because there's a tendency to think that if you do close path, that's it. You're finished now and it should draw it. But it doesn't mean that at all. It's just a way of allowing you to type this without having to remember the numbers. So when they do that, so we've got back to here, and now we do another move and do move to 100, 200, which is going to be 100, 200. So it's there, right? So we've just moved down here. So we're still on the same path. I know it looks, because these are going to be two separate triangles, it looks like two paths, right? It's not. A path doesn't have to be a single closed shape. It can be a whole bunch of stuff. So this single path has actually got this triangle element, and then we do a move, and then we drew some other lines. So we do the 150, and then we go across to 200, and then we go back. So we've done another segment, if you like, of the path. And then for the third part of it, we do move to 300, 300, which is over here, which is the center of this thing called an arc, where an arc is just like a partial circle. And then we draw the arc. And the way the arc works is you specify the center XY coordinates and the radius, and then you specify two angles. So that's the first angle and the second angle. So over here we've got 300 by 300, radius 50, starting angle is 0, and the finishing angle is 1.5 pi. And if you just remember how that works, that's pi's a half circle, so it's 1.5 is the 270 degrees. And you can actually see here from the drawing order that in this case it's actually drawing it clockwise. So we started with angle 0 and we went on to 1.5 pi. If I'd gone on to 1.2 pi or something, you'll see that it just comes up a bit less. So that's what's happening there. Okay, so So what we've done here is we've used these little tools like the ability to move and draw lines and draw arcs, and we've used those to assemble a path that happens to be made out of what we would describe as three things, but that's just what it looks like to your eye. We made this path out of three things, and then we draw it, and it's the fill and the stroke that draw it. So it's worth pointing out that if I hadn't bothered doing the fill, or indeed the stroke, you wouldn't have seen anything. So watch out for this when you're using this system, because there's a slight tendency, you maybe write this code and think, okay, where are my lines, right? But it doesn't draw them straight away. Turns out there are reasons for that that relate to the way graphics cards work. When you're drawing stuff on a graphics card, the system really wants you to batch them up into quite a large number of objects that you then kind of draw all at once. And this API was designed with that knowledge in mind. So what happens is you describe a shape, but nothing really hits the screen until you say, now actually draw the thing, please. So it's worth being very aware of that. So the actual draw the thing, you can either do the fill part, which will do that. That will draw the filled interiors. Or you could do the stroke part, which draws the outline, which is like that. And notice, by the way, that this thing doesn't join up. Because what's happening here is the arc part is only this part here, and this initial part is just because I did move to 300, 300 down here. If I'd done move to, let's say 350, I would have started at the right-hand side. So that's the arc part, is just this. Okay? So you can do the fill or the stroke, or indeed you can do both. And again, this is why, because the context thing remembers the path. So it's like, we created this path, and we can fill it, but filling it doesn't erase the path either. You can fill it, and then you can go and stroke it, and it's the same path being drawn with a different style, like that. And because I changed the endpoint here, the closing behaviour is a little bit different. But again, if I brought it back to 300, it would look like that. So this idea that the path is preserved is also really important, and can also be a pain, because it means that if I were to, do CTX fill again, it would actually go and do the work of drawing the path again. The path didn't get erased, but you can't really. It's funny, you can see the difference, because you can see that it slightly overrode the stroke. Don't know if you noticed that. Did you catch that little change? No, maybe not. I'll show you. Let's go back the way it was. Okay, that's the way it looked. The thickness of the stroke, I haven't actually specified, but you can see that there's this boundary line is here. If I now say context fill, I'm telling it to take that shape and draw it again, but now it's going to draw it basically on top of itself. It's the same shape being drawn, and it turns out when you draw it on top of itself, it's going to overwrite probably about half of the outline stroke. Half it's on the inside, half's on the outside. So you just watch, you'll see it just get slightly thinner. Okay, and that's just drawing the same shape. The really annoying thing about this is that if you're drawing multiple, if you're doing multiple paths and you forget to clear the old one, you might go down here and write some code to draw some new lines. Like if I did dot line 2, something like that, thinking I just want to draw a line, and I'm just drawing my line, and let's say I'm drawing my line and stroking it like that. And I would look at that and think, oh great, I drew a line, no problem. I didn't just draw a line. What actually happened was I drew a line and I redrew all the other stuff as well. Okay? So you have to watch out for that. It's a slight inefficiency. The reason is that I haven't started a new path yet. What I really should have done for efficiency is I should have said context begin path to tell it I'm starting again with a new shape. And if you forget to tell it that, you might not notice the difference, but you'll have a big performance difference, because if you draw 100 different things, what's actually happening is you'll be drawing the first thing 100 times, and the second one 99 times, the third one 98 times. This will get slow eventually, and at some point you will see it behaving badly, where it's like a really annoying error mode in this system. Yes?
Is it possible to begin a new path and then go back to the old path? Because I know it's like hours.
So the question was, is it possible to begin a path and then go back to the old path? I actually can't remember off the top of my head. I can't think of an obvious way to do it. It might, I don't think the context object would have memory of previous paths. I don't know what, if you actually tried to copy the context or something, I don't know, but I wouldn't want to rely on that behavior. Basically, once you start a new path, the old one is thrown away. But the killer thing is, I kind of feel like I want to have an end path, and I think actually the Canvas API doesn't have end path. It's got this closed path thing, which means something else and is not what you want. And it turns out that when you want to start a new path, you don't say end the old path and start a new one, because I guess it's kind of redundant. You know, you're going to say end path, start path, end path, begin path. So you just say begin path. Begin path means throw away the old path and give me a new one. And it's important to remember to do that. If you're drawing little individual objects yourself, you kind of usually want to start with begin path. Otherwise, you'll end up redrawing anything that had previously already been drawn. So bear that in mind. It will be relevant. Okay, I think I've got one more of these to show you. Step 9, which again is a little bit about subtleties about where paths begin and end. You'll see the change here is that I am not stroking the first shape anymore. But yeah, I know. But I'm still stroking these two, and I'm stroking them harder. I'm getting myself in trouble. I'm just doing this for contrast, so you can see what's different, right? So what's happened here is it's basically the same set of drawing primitives, but when I did the path, I did this fill part a little bit early. So I did the fill only after drawing the first triangle. Then I did begin path because I want these new objects to be separate. Did the separate one, and when it comes time for me to I fill them just in the normal way, and when it comes time to do the stroke, I proceed that with a line width setting. Okay, so line width is 5, and that's why you can see that these two are thicker. The point is that this illustrates that the line width part applies to the active path, which happens to have to what a human would be 2 visual elements in it, right? And that's why they both get affected by it. If I had, let's say, not done begin path here, then it means that I would actually have been doing all 3 things as one single entity, and then you would get 3 thick outlines. So again, just the subtlety about making sure you understand when you're changing from one object to the next. So I think that was really the only point I wanted to convey there. I could show you another variant of it. For example, if I made the arc separate, if you only wanted the thick boundary on the arc, the way to do that would be I'd have to make sure that I did the drawing of the previous one up here, so that it actually gets written out to the screen. In fact, I'll actually show what happens if I don't do that. I'll comment that out. If I forget to draw this one and I go down here and I say begin path, just so I can see the arc on its own, because I only wanted the arc to have the thick boundary, let's say, then I would get that, but it would have totally obliterated this guy because we did begin path without ever remembering to draw the previous one. So then the fix would be draw the previous one, and you see that the previous one gets drawn, but without the border, because the border came in down here, at which point we had started a new path that only contained the arc. So this is I think the kind of most annoying part about using Canvas is just keeping an eye on all those things. That's why I'm explaining it to you. All right, but that's fairly useful, and it lets you draw shapes fairly quickly in a way that's not too unpleasant. Oh yes, and this link here just takes you to a kind of reference page that basically runs through just the same stuff as I did. If you want to just check this stuff yourself, you can see how it goes through and does the things that we just did. I think it's basically the same stuff. Here's a little interesting one. I showed you how to use a linear gradient. Other gradients exist. This is a radial gradient, where the gradient flows, you can maybe see there, from the center out, which sometimes is prettier than linear gradients. You might find that worth knowing. Okay. Homework. So you now know enough about Canvas to do this week's homework exercise, which is inspired by a thing called Watchmen. How many of you know Watchmen? Oh, good. I'm glad that's one of my old cultural references that hasn't died entirely. How many of you have seen the film, the Zack Snyder film? Okay, good, right? Because I know there's been like a TV series, which I haven't seen, and there's the comic book, of course. How many read the book? Not too bad, not too bad. All right. So I'm just going to show you the opening fight from Watchmen, because it leads up to something. And I think it's quite good. can maybe turn the light off. Could somebody just switch the light off just so we can... No, I don't want any shoes. Let's see.
Just a matter of time, I suppose.
That's why, darling, it's incredible that someone so unforgettable thinks that I am unforgettable too.
It's a joke. It's all a joke. Mother, forgive me.
And forevermore, that's how you stay. That's why, darling, it's incredible that someone so unforgettable thinks that I am unforgettable too.
Okay, and could you just switch the backlight back on again? So, as the more astute among you might have guessed, your homework is to draw the Watchmen smiley in Canvas. What?
With the blood spatter.
With the blood spatter, yes. So you've got two choices here. This is the old comic book style that used this little kind of squirt insignia across the eye, and they also have the movie style one that makes it more of a sort of more realistic looking little splash. Constructed using Canvas. Now, some of you might know there's a thing on Canvas called Draw Image that allows you to just copy JPEGs and stuff. No, you're not allowed to do it that way, because again, it would be cheating. Right? I mean, I'm not being deliberately perverse by making things hard for you, but I can't make them too easy either. Okay, so you're not allowed to use that one. You have to use the drawing primitives that we've just reviewed. Now, funnily enough, Canvas does not have an ellipse routine built into it, which came as a bit of a surprise to me. It's quite an obvious primitive. So I made one. It turns out you can kind of do it. There's a way to create circular arcs and stretch them so that it ends up being like an ellipse. The details of that I'll actually explain next week, but I haven't taught you them yet. So I'll just give you an ellipse routine because you're going to want one. I've got some instructions here which I'll run over briefly just so you make sure you can see what you're supposed to do. As the questioner asked, yes, blood is compulsory. Blood is compulsory is actually a quote from a play called Rosencrantz and Guildenstern Are Dead that I quite like. But anyway, let's focus on the instructions so you can see what you're supposed to do. So they're up here, and obviously there's a real homework exercise that links to this, but it's kind of the same as before. When you've got a fiddle, I tell you how to set up the basic thing, and then you work from there. So the idea is you go to GS Fiddle, do that. you have to, so I use square brackets to put the different sections in because there are two parts to it, right? So you need to copy out this part here and plonk it in like that. And if you just ran that on its own, you would get these two reference images that I've put for you just so you can kind of keep an eye on roughly what you're trying to do. And then the other part of it here, it's down at the bottom. Again, you have to just not go right to the end because you don't want to take the last square bracket. That'd be a bug. And stick that in here. And this is my context to let you run the thing in. So it's mainly the instructions, which are very explicit, by the way. And just to make it clear for you, I've actually given you the marking scheme. Because it's, you know, an artistic thing like this, there could be very subjective judgment about whether it's right or not. So I've tried to be as fair as I can. So the marking criteria is that there's 1 point out of a 25 little items for each of these features, which is just to make sure that, yes, you know, the circle's there, it's the right size, you've got 2 eyes, all, you know, all the basic sort of standard stuff. So the thing is, this should give you a very clear idea as to whether you've hit all the requirements. Okay. And then I've got a little bit of a harness to run it, which you shouldn't change. You need to work, again, because there's some automation involved in the marking of this. It's important that you just take this function called draw default smiley and you modify it to contain something sensible. The version I've given you simply calls my silly ellipse routine as a proof of concept, which only does that. If you do that, you will not achieve a high mark. I think you will probably achieve 0 if you do that. I've even made it the wrong colour just to force you to have to do something. But the point is, it shows that we've got the facility to create an ellipse, and in fact to orient it. You see it's tilted a little bit. That is because I've done some magic down here to fill ellipse, where I am in fact drawing a circular arc, and then I'm mucking about with it using a fancy thing that we'll explain next week. So that gives you enough to go on, and you just basically replace this function with some interesting code that actually looks somewhat like one or the other of these things. Ideally, they should both fit. Okay, just as we're talking about, are there any kind of questions that immediately come up about that? Or do you feel you know what's needed? I think it's fairly self-describing. And of course, I've tried to make sure that the things I taught you were sufficient to do at least the bulk of this. Maybe 1 or 2 things you should investigate yourself, like radial gradients, to make it look nice, if you want to do that. And a couple of little smart things, like you notice that technically the smile here is not of a uniform thickness. It actually gets a little bit thicker in the middle. And if you just draw an arc in a canvas, there isn't a way to say, oh, I want the thickness to change. But you might be able to achieve that effect by, being clever. Okay, so that's a little challenge for you. So this is not the end today. I've still got other stuff to tell you, but probably it's worth me stopping so this one recording isn't too long, and it's nice to have a recording that finishes with the homework. So I'm going to stop here, but this is not an invitation to go away. I'm just going to do the next thing quite basically immediately.